you are able to, you'll be receiving, events or the, tech updates from the community directly from CNCF. So please make sure to sign up. You'll be able to find it at the community.cncf.io. So that's one. Before we begin, I would like to share a few things. So this is a Cloud Native CNCF community event. So we're gonna be following the code of conduct. This is really strictly for the open source technologies, no commercial promotions or whatsoever. And also this is a safe space where you have any innovative ideas you can share safely, right? And then also exchange ideas. And this is a place where we want to incubate all the amazing ideas. Another thing is that so I don't know if you have you ever been to a KubeCon or Cloud Native Con before? Anyone? Yeah. Okay.
It's awesome.
Yeah. Wonderful. So if you have been, you know that these conferences are hosted in a major city in the United States, but Miami. So unfortunately, they haven't picked Miami. And I know there's so many, Kubernetes Cloud Native practitioners here, but we don't have the hub where we can get together and, collaborate. So we want to be the hub so that, CMCF will consider hosting their event, the conference in Miami in the future. And I'm sure that attendees would love to come to Miami, right? The beach and the beautiful weather. So, yeah, so I think, okay, great. So, and before we move on to the agenda, I would like to thank Cloud Native Now for hosting this event, and then also Nikki, thank you so much for helping make this really happen, and Defense Unicorn and Kwame for the helping with the refreshments. So thank you, Nikki.
Cool.
Well, I was going to say Nadia actually did my normal part. She did a wonderful job. So really, I just want to welcome you guys again. Thank you to all the sponsors, everybody for putting it together. And hopefully, to Tony's point, is that hopefully we can change that. Hopefully we can actually have them look at, South Florida and Miami as a viable place to actually hold conferences like this. Hopefully having some of these meetups more often and get you guys involved. So really, I'm just excited to hear what you guys have for us. Of course.
I'm in the birthday. I don't know you. Hi, my turn. So one more thing, I would like to have a round of applause for Chris, and the reason why is because yes, please go ahead. We have a hidden gem here because the logo that you see here, the one that is listed for the 10 years anniversary, was made by her. Wow. Out of 30 logos, she was that her logo was the one picked. Of course, I also appreciate that Kubernetes team supported on that. But I just wanted to recognize that because, the interesting part about community, especially on the tech community, is that yes, we always recognize the technical people. We should. But there's a lot of work, a lot of stuff that we need to recognize that is done by non-technical people like Chris, like Nikki, Nadia, Tommy, which basically make this possible, right? So I just want to recognize that because otherwise it would be just a lot of nerds talking about this and that would be it. We probably won't have food, but we're talking about code. So, all right, so we're on a birthday. I don't have much time, so I just want to address something. I don't know in your case, but we have Latin birthday. That's the perfect scenario for our parents to basically tell all the embarrassment stories about us, everything, and that's the one that you pick. So Kubernetes will have the same. So I'm going to talk a little bit about Kubernetes, but I'm going to take the opportunity because the guy just here, he's going to be talking soon here about his project. But I don't know if you remember the story, but Kubernetes came around, when they come with the board paper and everyone was excited about containers and everyone wanted to be using Docker and all that stuff. So I was working with Josh as lecturer at that time, and we have this issue about the API. I said, you remember the part when we were saying, oh, let's use Con. Remember that? Everyone wanted to use Con, but at that time Con was using containers and all that kind of stuff, and we have to figure it out. So we were using all the crazy stuff that you know, Beanstalk and all that. But it happened to be that we were reading about this scheduler, and we were like, oh, let's take. So we started doing some research, and we found out that Kubernetes at that time was just a basic scheduler. I'm pretty sure that they hate me because I brought that up and told them, let's use this, and it was tough to set up. So the reason why I'm bringing this as a story is because even though it was tough, it did solve the problem at that time. But you know, fast forward 10 years now, basically became the open source of cloud. So now everyone is using Kubernetes, and I'm really proud of that because what I wanted to basically take out of this story is that yes, we had a lot of pain, we had a lot of discussion back and forth like this. This doesn't work, we cannot make it happen, I don't know what's going on, but at the end, it did solve the problem, and if I'm not mistaken to this day, still running on Threshold. And I can tell you that happened in multiple companies. Right after that, I was working at Vista, and then we also did the same thing, and today's day this is running. So try things. Even if it sounds crazy, even if you think, oh, this might not work, try. Because at the end, that's what technology is about, is trying new things. I know that we all talk about AI, and you know, probably someone would come up with like, oh, well, now the new kids, the world will be AI based, probably. But at the end, if you look at it, you have to run somewhere. Kubernetes actually solved that problem very well. You just have a really good project that you can run AI on top of it. So I'm just creating that code right there. So once again, I don't have enough time because I know that it's going to be case talk right coming. But I wanted to share that embarrassing story about how we failed multiple times using Kubernetes at the beginning, but at the end it come across very well, and today's days is for multiple companies. So with that being said, thank you so much. For those that maybe don't know me, and I unfortunately do the introduction at the end, I'm Miguel Ramirez. I'm a CNCF ambassador of the Kubernetes and CNCF. I'm also an OSPO ambassador, so you're listening a lot of the open source soon about here in the South Florida. And by those that don't know, the South Florida group is one of the first groups that was created. It just happened at COVID, right? But at the end, we were one of the first groups about Kubernetes and Kubernetes here in South Florida. The domain I used to run this meeting back then, and I'm happy that we are taking this group again, and we want to do more talks. We want to support the community. So thank you so much for being here. And I'm going to pass that to Casey. It's amazing. I love this project paper. You should check it out. So,
thank you. Angel, thank you so much. You know, I love working with Wendy, and obviously all the rest of these companies. I come from Defense Unicorns, but it's very obvious when a company actually cares about the community, cares about open source. You know, they actually invest in open source because it is an investment. It takes kind of care to grow it. Speaking of embarrassing stories, I have some embarrassing stories. Hold on, sit down.
oh, okay. Kids, close your eyes.
Yeah. All right, here we go.
It's really embarrassing it's on a flash drive and now it's just downloaded.
Oh no,
That would be embarrassing. This would be flash drive. It's not flash drive, it's super quick. You say yes.
All right, so who knows about admission controllers? Kubernetes admission controllers? All right. So this is gonna be a brief, but kind of throw a primer on admission controllers. So I'm Case. I'm a software engineering lead on a product called Pepper. Kubernetes contributor. Check out my LinkedIn. defense unicorns, and we solve like very hard problems at scale, and kind of for like Department of Defense and kind of industries where it's very hard to deploy software notoriously. So like air gap systems. So we have some really interesting problems. But first of all, happy birthday to Kubernetes.
Woo!
So who's ever been interviewing an engineer that says they have over 10 years Kubernetes experience? Because I've seen some of those. It's like,
That's a lie.
That's a lot. For a job description, here's one from IBM that says back in 2020 they were requiring 12 years of Kubernetes experience. That's very senior. All right. All right, so the admission process in Kubernetes. So this is for a t-shirt, actually. If you can name the 2 admission phases of Kubernetes admission control in a t-shirt.
We have to watch the video before we know the answers.
Definitely.
Oh, I'm after presenting. One being native. There you go.
Very close. You get a sticker for that.
Holy cats.
And so that's not absolutely right. Who knows Kubernetes and former pattern? All right, anyway, so all right, so what is admission control in Kubernetes, right? And actually, I guess we should start with like, what is the admission of Kubernetes? So there's 2 things that if you're, maybe if you haven't heard a lot about Kubernetes, you might get confused. There's an ingress, and that's where the traffic goes into the cluster, right? So there's like, edge gateways, all these gateways, that's what the ingress is. But when we say admission, it means what can be admitted into the Kubernetes cluster. And there's 2 phases. Now you know those 2 phases of the t-shirt. In case I ask you, there is mutating and there's validating, right? And so there can be as many mutating webhooks as there needs to be. So there can be 10 mutating webhooks and 1 validating webhook. There can be 5 and 5, it doesn't really matter. But the important part is mutates always go before the validates. So I'm going to break this little admission problem down. Imagine you're at like a discoteca, right? Like back in the day, right? And there's like this long line outside to get into the discoteca. So one thing typically, if you're in the line, there's going to be 2 types of bouncers. There's going to be a mutating bouncer and a validating bouncer. Now there might be more than 1 bouncer, right? There might be more than 1 mutating bouncer. But what the mutating bouncer can do is it can literally remove your hat, right? If you have a hat on, the club says no hats, it can remove your hat. If you have the wrong shoes on, it can give you the right shoes, right? The next thing a mutating bouncer can do is it can give you a ticket. So it can say like, hey, you can buy 2 drinks and 3 pieces of food. The idea is that once you're into the club, we don't want one noisy neighbor, one rich person at 8 p.m. buying all the drinks in the club, and the club owner doesn't make any money for the rest of the night because they don't have drinks, and then no one wants to be in the club. So in the validating webhook or validating bouncer is going to say, let me see, do you have the right shoes on? Yes or no? Do you have a hat on? Yes or no? If you don't have the hat on, you don't have the shoes on, you can go in. So the validating webhook simply is going to say you can or you can't go into the cluster. The mutating webhook can change things. It's very, yeah. So just kind of in that same vein, what are some things you can do on a mutating webhook? One, you can add a label. So when something's going into your cluster, you can say, this has been mutated, this has been seen. You can add an annotation. You can say this is coming in the US East region, US East 1. You can decide pod resource limits, right? You don't want one pod starving your cluster, so you can assign sane defaults. You can set security context, right? So you can say no pods can run as roots in your cluster. You can say no pods can run privileged, because what happens when pods run privileged sometimes? They escape out of the container into the host OS, right? And then the validating one. It basically says, like, let me see the shape of this Kubernetes object. Does it look right? If it does, you can come in. If it doesn't, I'm going to reject you. And so this is really a way we're starting to talk about sane defaults or global configuration, right? If you're an enterprise, right? Who's worked in the enterprise? Like these teams end up solving the same problems again and again, whether that's security context, whether that's storage volume, storage classes, all these things that you really need to solve once and then set a standard. That's really what the webhook can do. So there's like types of admission phases. There's like, you can watch for creates, you can watch for updates, you can watch for deletes. This is a mutating webhook configuration. It's ugly, I'll give you that. But basically it's like, you know, you make this configuration, it's like, hey, page me, let me know when a pod's created in this cluster. I want to know about it because I want to mutate it or I want to validate it. All right. So now we're going to get just a little bit technical on the Kubernetes side, right? So what does it actually take to build a webhook or a admission controller? So depending if your admission controller is mutating or validating, you're going to need a mutating or validating webhook. And what that webhook entails is really like 3 pieces of information that are actually relevant to this talk. One is the service, right? So it goes to admission, it goes to the KubeAPI server. KubeAPI server, if there's an admission controller, it's going to read the mutating webhook configuration, validating webhook configuration. It's going to say, where's the address? Where's the CA bundle? How can I trust this? And it's going to send the traffic to this address, to this service address, right? That's going to also have a failure policy and a timeout. And a failure policy in a webhook basically means if I cannot contact the service, if I'm getting a service unavailable, what do I do? Do I fail it? Do I say, I'm not going to let any pods go into the cluster because I can't talk to the admission controller, so I'm just going to fail it? Or am I going to ignore it, right? So that's one thing. And imagine ignoring those. For a validating webhook that's put there for security configuration, would be very, very dangerous to ignore something that's going to the cluster just because your service is down, right? It's kind of like a scaling problem, but you definitely shouldn't ignore it. And then there's a timeout. And the webhook timeout basically says, how long am I going to wait until the server gives me a response back before I consider this request dead? So those are the really a couple of things. And then Kubernetes admission, you're just passing around admission review objects. And that's it. It's like it's really just a schema that basically like has a UUID. You can accept it, you can reject it, you can actually add a JSON attached to it. It's just basics form coded. But you're basically just passing around these admission review objects. And so, you know, it's pretty ugly, right? Like, who likes YAML? I love YAML, but a lot of people don't. Actually,
What's the
YAML
alternative?
project, you're supposed to hate it, YAML. I hate it.
What's the
Oh, there we
alternative?
go, there.
What's the alternative?
Yeah. Oh, so check it out. Here's a validating webhook configuration. We can kind of see here's the service. As a service, cover system namespace, the path to the URL that Kubernetes API server is going to send that admission review request. Failure policy, do I want to fail? Do I want to let it in? You know, whatever. Some things I want to ignore, like I'm not going to touch root system namespace. That's the control plane for Kubernetes. Don't touch that. Not really a good idea unless you have a really good reason to touch it. And then your rules. It's like, what am I looking for? I'm looking for create, update, deletes, secrets. And then of course the GVK. That's like the group, the version, and the comments. Now, in the center, you're going to see an admission review object. So this central admission review object is what Kubernetes API server is going to send the admission controller, right? So you're going to actually see the object that's coming in through admission. And why is this important? Because you might want to change it. You might want to mutate it. You might want to assign, you know, sane security default values. You might want to just straight up deny it from coming into the cluster. And then to the right, finally, you have what the admission controller is going to send back to the KubeAPI server. So we have one at the very bottom. That's like a validating webhook response. So it's an admission review object. Basically, you're saying it allowed its faults. You're giving a message why it's not going to be allowed into the cluster. And then the top, this is more like a mutating response, where you're actually going to mutate the object that's coming in through. So remember, there are as many validating controllers, as many mutating, as many validating webhooks as you need. These are occurring before the object is in NCD. So you see something coming through admission. Let's say like hits your mutating admission webhook. If you query that in NCD, it's not going to exist yet, right? It's not going to get into the cluster until it passes admission control. And so this is going to give you a lot of power, right? You completely own every single aspect of the cluster. You can also control like the behaviors of the cluster this way. So, right, it's when a config map is created, this is Pepper's code right here, right? So when a config map is created with a given name, I'm going to go ahead and mutate it and say Pepper was here. Then I'm going to validate it to make sure that config map has a given label. If it does, I'll let it into the cluster. If it doesn't, I'm going to deny it. Then the last paradigm doesn't have anything to do with admission. It's Kubernetes watch pattern, but we'll get to that later. It's just a little bit of sugar added on top. That can be very useful at times. So who's heard of Istio? Okay, right? So does anyone know just off the top of your head how Istio uses its admission controller just one way? Those sidecars, right? It adds those envoys into the containers as sidecars. Who's run OpenShift? Who likes OpenShift? I used to work at Red Hat.
I plead the fifth.
Yeah. I do too. But you know, OpenShift, you pass upon OpenShift, and you're going to look at the run as user. It's going to be like 65,000. So if you're like binding volumes to the pod, and then the permissions get all screwed up, yeah, that's going to happen when you mutate the run as user like that. Zarf is an air gap tool. So basically, you want to install Kubernetes application on a submarine where there's like, you know, you're under the water. What it basically does is it mutates your pods and sets them to an internal image registry, like a 127.0.0.1 that should be seated on the nodes. So it's just mutating the image from the pods. And then, you know, Kai Bruno is validating webhook, mutating webhook. But you create your policy with Kai Bruno with YAML series. All right, so, you know, why would you care about this? Why would you use admission controllers? One, local standardization across clusters. Like, if you own a fleet of clusters, maybe 200 clusters, let's just say that are dispersed around the world, you want to make sure that they have a certain security posture, and that's like if you're going to get certified, have certain applications you're working with giving customers, you have to have these security standards in place. But also assigning sane defaults. So like, if I have this crazy AI application that's going to like churn through a bunch of like CPU and memory, like maybe I want to say like, you know what, I want you to just kind of like restart because I don't want you to starve my resources. My resources are finite. I mean, I can scale to some extent, but I'm going to put a cap on what I'm willing to scale for because it's going to be expensive. Adding enhancements to the stack, like throwing in proxies every time a pod comes into a mission, just adding like a sidecar similar to Istio. Validating configuration, like let's just say I have a custom resource. It's called a web application. And the web application is going to deploy a deployment, a service account. Maybe what I want to do is I'm going to watch the web applications, and when I see a web application CR come through, I want to first validate that the shape of it, the schema looks right. And if it does look right, I'm going to deploy the underlying deployment service, everything that I need to actually deploy a web application. And then, you know, building operators is a very popular one, Kubernetes operators. And then you go like multi-cluster. When something comes in this cluster, replicate it on another cluster. So we kind of already talked about this, but like, you know, security, automation, reconciliation, so many others. Basically, how my app uses admission controllers is to do very advanced configuration. So we want our customers, if they're on submarine, if they're in an airplane, wherever they are, if they're in a data center because they're a bank and it's very, you know, classified or whatever, we want them to just deploy an application, right? I'm just deploying my simple web app. But what's it's going to do underlying is it's going to, one, deploy the Istio gateway, deploy the virtual service, the destination rules, the peer authentication policy. It's going to deploy, you know, let's just say it's gets data scraped with Prometheus. It's going to deploy the service monitor, the Prometheus rules. So the user just deploys their application. They're like an application developer, right? They don't really need to know about the underlying stack. But when the pod comes in through admission, everything is actually hooked up because you're going to see everything that comes through admission. So I'm going to deploy this application. Okay, it needs to be scraped. It needs to have network policy. So then it can actually kind of orchestrate all of that under for you. And then we talk about Pepper. So Pepper is kind of like a framework. fully open sourced. The idea is to actually donate it to the CNCF in Q3 of this year, maybe Q4, we'll see. It's really similar to like Operator SDK or KubeBuilder. Who's used Operator SDK or KubeBuilder? Nice. Yeah.
I stopped using it.
Oh, you did?
Because you.
Cool. Yeah, I mean, I love Operator SDK. I used to like build operators like constantly at Red Hat. It was kind of my job to some extent. But it's a little bit different than Operator SDK. It's a little bit different than a Kubernetes or Gatekeeper because it has aspects of all of this. And now there's nothing wrong with these projects. Actually, I've used them all. I really enjoy them all. But it might be a reason to switch to Pepper if you're actually using 3 different projects, 4 different projects, because it can kind of do all of that. And then it comes with a Kubernetes client that has server-side apply. And server-side apply is a way to apply only the deltas of the resources. So what I mean by that is it's a very kind of sophisticated way to not blindly apply resources that already exist in the cluster. If there's a pod that's just like one field's changed, it's going to only apply like the deltas. SSA, server-side apply, is like really important in today's age. All right, so yeah, to build a validating or mutating webhook, you gotta have a lot of configuration. Like you have to build your mutating webhook configuration. Like that's annoying, right? You have to meticulously get all these things. You have to have a CA bundle, right? You have to have trust within Kube API server. You have to create a secret with TLS cert, TLS key. Deployment, unless you're gonna go YOLO and just deploy a pod, that'd be funny. But you have to have a service, of course, your secret, which contains creds. But this is an actual Pepper example. So in Pepper, you can say when a Kubernetes resource, in this case it's a pod. This could also be an Istio gateway, it could be a virtual service, it can be actually anything. But it's like when a Kubernetes resource is phased, is created, is updated, it's deleted, whatever, right? You can mutate, you can validate, you can watch, you can reconcile. Here, it's mutate. First of all, what I'm going to do is I'm going to say, if it has the label ignore me, I'm going to, if it doesn't have a label ignore me, I'm going to kind of ignore it. I'm looking at through the init containers, I'm traversing through, an init container is just a container that runs before your standard containers. I'm going to look through the ephemeral containers. I'm going to look at the security context, and this is the part I really want to point this out. This is why it's like really for everyone, right? If the security context is not defined, then I'm going to apply some sane defaults. In my opinion, it's sane to say like if you can't run as root, you want to run as like user 1000. Where we're talking about like people escaping out of containers, out of pods, getting onto the hosts, stealing like credentials, and getting to a lot of problems. But yeah, you can basically assign these same defaults, or you can say like, hey, I'm going to put this label on the pod that says ignore me. Like I want to run as root, don't worry about it. Just let me control my own destiny. But with Pepper, you have all of these ways to program this in. So this is what a module author can do. The module author, if it's your org, if it's your cluster, you decide who can get in and who cannot. So you can actually program like, just leave them alone. Take this person. Now, this is another example where we're actually talking about storage volumes writing to the file system, right? So it's kind of an anti-pattern to write to the file system to like, to mount some volume to your pod and then like write directly to it, because then you're actually writing to the node. You can install agents, a lot of bad things that can happen. But this one, we're basically like looking at a pod, looking through all the pod's volumes and seeing if the volume type is one of the allowed volume types, or if it's an allowed volume type, it's fine. If it's an unallowed volume type, you're going to go ahead and reject that pod because it's just a security risk, it's a vulnerability. And then, another host path, right? When it's if your volume is not read-only, is basically another one, right? Like you don't really want to be able to write to a host path because then you're writing directly to the node. And then, of course, the noisy neighbor problem goes back to kind of like the club. You're a club owner, you want to make as much money as you can because you're making money when people come to the club, they have to pay. You want them to stay there, hang out. But if the first people to go state, after validate, it's in etcd, okay? So now there's the Kubernetes watch, and this is literally just a call to the Kubernetes API server with watch equals 1, and it's very simple actually. And so what Kubernetes watch does is it watches resources. It literally watches resources to see when they're created, when things change, and it's going to send you the resource and the event back. And this is how Operator SDK is made, KubeBuilder, a lot of Kubernetes controllers. So the reason why you might want to use watch instead of like an admission controller, or maybe like in tandem, is because if you deploy an admission controller, like you're only going to get new things as you come through admission. There's going to be a bunch of things that already exist on the cluster, so you want to be kind of like watching them, watching the deltas. Second of all, watch is not limited by Kubernetes timeout, like webhook timeout. It can wait all the time it needs. And so this is more of an operator pattern that we were kind of looking at earlier. So we say when a web app is custom resource, web app is created, we're going to validate, right? If the web app CR needs 200 replicas, we're going to go ahead and deny it to the cluster. But then we're going to reconcile. So Pepper has reconcile and watch, as well as mutate and validate. What reconcile does is it puts each event that comes back from Kubernetes watch into a queue, right? So it's like first in, first out. So you pop these events into a queue. So the reason is the time it takes to actually reconcile a web app, right? And let's just say theoretically, what the web app does is it deploys an underlying deployment, a service account into the cluster. Well, sometimes the web app to reconcile a process might take 5 seconds. Sometimes it might take 10 seconds. So if you really want to process them in the order it came in, so you have to actually read the CR. So you have to actually process things in a queue. The more higher your volume comes in, the more you actually want to queue things up and process them in the order that they came into. Second of all, we're looking for custom resource definitions with a certain name. So you're actually watching for those. So if some bad actor internal to the organization or outside of the organization deletes a custom resource definition that you're working with, you're going to immediately register it back. You're going to redeploy it. You know, likewise with the deployment, we're working with just this simple CR, a web app, right? It's got replicas, it's got like color, it's got, you know, a language, something like that. But what actually a mission controller does in this controller is it goes and deploys the underlying resources. So basically, if someone tries to delete like a deployment, we're not going to let them. We're just going to like redeploy it. It's fine. You can delete it, but we're just going to redeploy it. So this is a way to make your application kind of foolproof. Like no one's going to really be able to mess up your application. It's going to have very, very high availability. And the second thing that Pepper has is it has a store and an on-schedule mechanism. So I mean, this basically came out from another team, another request from a team that was actually maintaining a cron job. So we actually made the schedule so you can actually, as a scheduling API and a store, you have to set things in the store. Just kind of make these decisions a little bit easier in English. So we really want you all, the community, to contribute to Pepper. It's completely open source if that's something you're interested in. You can, if you're using Pepper, you can always write issues, give us feature requests and suggestions, or take on a PR. That would also be something we'd like to welcome. Before I continue, are there any questions on admission process? Yes.
Should I stand?
If you want to.
I'll stand. Hi, my name's Tina.
Hi, Tina.
My question is, I noticed that a lot of it's like database management, very similar to SQL. So is this its own program that's very similar to NoSQL or SQL handling?
Really good question. Really good question. If I had to compare it to a database, I compare it most to NoSQL because it's all backed by etcd. But yeah, it does Any other questions? Okay, really good question. All right. Now I have one question for a teacher. What are the admission processes or admission phases in Kubernetes? What's that? Yes, two teachers. Okay. All right. Last question. Is Kubernetes watch, when you're watching something, you get a watch event from it, is it technically in the cluster?
No.
All right. Cool. Thank you all so much. It's been a huge pleasure to be here. And enjoy I love being in the community and love we're doing this and that we're growing this up for the community. So it's been a huge pleasure. Thank you all.
Thank you, Casey. Sure, we have no more questions? I was clear, right? It's clear. Awesome. Now that I'm seriously, I want to mention something. What I said about that switch to paper is true. I just didn't say it for the sake. It's because I was doing a lot of my work with the cube builder and Kubernetes game. Remember that he gave the first talk online, and right after I just dropped the other things and away. The reason why is because most of the stuff that we're doing on security, especially on security, is rules. So why build the whole shebang trying to do everything and go when you can basically do TypeScript and just do it very simple? And especially, I think the one thing that I like about paper, which is why I'm worrying so much for the thread to be adopted on the CNCF, because for those that maybe Golang is not what they want to do. They just know TypeScript, right? That's what they like. It gives an opportunity to get into the Kubernetes ecosystem because now you can write in the language that you like, the one that you know best, and all you need to do is just the rules, and take all the hard work out of the equation. So appreciate that you guys built it. I'm a big fan.
Thank you. Thank you so much. Hey, it's amazing sharing with people like you. It's an honor.
So I think the next one is Josh, right? Good, man.
Hey guys, glad to be here. Nice to be out. If I was home, this would be the time of the night Netflix would be asking me if I'm still paying attention. Landed up here safely on 995 from Fort Lauderdale. It's been a while since I've commuted up here. Remember the I might die 95 trips every day when I was commuting. Now I take the express lane, you know. Not for safety though, the satisfaction of passing by people stuck in traffic.
That's true.
The little things in life, you know. That,
You gotta laugh at them as we're passing them.
huh?
Laugh at them.
Oh, I do. I'm like, loser. I turn into Donald Trump when I car.
Except when there is an accident on the express line. That's no fun.
Oh, can I do this thing? This is gonna be a little bit more of like that was like the in-depth, like, you know, kind of expert deep dive into something like this of Kubernetes. This is gonna be a little bit more of like a little high level. I was like Angel was saying I was started kind of almost right when Kubernetes started 10 years ago. But before that, before Kubernetes even existed, we had to people were trying to come up with ways of how to do container orchestration. We were all searching for different tools and going through all of the new approaches. We went through Rancher for a little bit, and I had found one that I was really excited about. It was called Deus.
Oh yes.
And that team ended up being pretty pivotal in the community. They ended up also building Helm, which became kind of one of the standards in packaging and containerizing, groups of applications and all the different configurations that you have to send into your clusters. And so recently, I was kind of tasked with getting myself back up to speed on kind of the state of the art. So I put together a little container orchestration package. The idea is that you can, just run make a couple times maybe. Just once, if you're lucky, but probably a few times. And then it'll deploy for you, a Kubernetes cluster and all the network, this is in AWS, I should preface this. Obviously your environments or whatever, in my condition it was like, let's just deploy it to AWS. So it's going to deploy all the networking infrastructure, it's going to deploy an EKS cluster, and then just all different packages and add-ons that you would want to add to your cluster, and then help you to launch a three-tier application with a front end, a back end, and a database, and do it all with kind of like security practices in mind. Yeah, here we go. I'll give you guys a little look through. So first off, we'll start with the goods. This is the application. It's just a simple, just a simple application. It just has a front end and a back end. And I just logged in to prove that it worked. And, just that's it really. So this application is defined in our charts repository. So these are the Helm charts. All the different configurations are going up to deploy this thing, right? How many people here, before I keep rambling, how many people here are like Kubernetes administrators? Okay, a few of you guys. Okay, so here are the charts. These are a whole bunch of just configurations that are just going into telling you how it's going to run inside of Kubernetes. There's a lot of different components. There's services, there's pods, and then you can see inside of here, this is a deployment. And this is telling us, you can see here, like what image we're going to pull and from what repository it's going to come from and all that sort of stuff. And all this stuff comes together and does, deploys our application. So one of the cool new things that I discovered was that there's a whole new way of doing kind of the deployment automation. Instead of just running Helm directly, this thing called GitOps is getting popular. And so what that does is it kind of syncs your repositories to a kind of deployment mechanism. So whenever I have like a change, my applications kind of just go out automatically. Connections.
How does it know this change?
So it's got a connection to my
GitHub action?
my GitHub. And so if I make a change, it'll show like it's checking. It'll say like, oh, there's a disparity, and let's see. Okay, my connection's back up. Okay, so yeah, it has this cool dashboard. That's one of the other cool things about it. It's got a nice, pretty UI that as an automator I'll never end up using after this. But you can see it kind of demonstrates all these things. And if one of these were out of sync, you'd see here in the sync section that would be like yellow or something, and then you can just go in here and manually go and tell it to like go and sync itself. But if you just automate this stuff, it'll just go up and it'll look on its own. You'll have a process for delivering through different environments and stuff like that. Got Argo doing deployments, and if you see here, so let's see, like up front end. So in here you can see it breaks down. This is that code in the Helm chart in a visualized form. So all those different little components, those are all being defined inside of here. Basically it's telling you how to deploy through all this fun, detailed most leading edge approach, so it's like the ones who are kind of starting to, are staying up with the current trends are starting to use GitOps.
I have a really dumb question. Is Helm installed locally or is it in the cloud? 'Cause I've heard of it, I just never had time to look into it.
Okay,
Is
yeah, interesting, that's a great question. So it's actually, you can consider it as like a kind of a templating engine
Okay.
for defining all of the resources. So each of those, each of these pieces, you know, that you're putting together here, you know, are individually defined, and like this gives you a way to kind of template those. So if you want to pass in like different variables, if you maybe you want to do a 3-tier application like this one, but instead of you know, instead of one database, you want to plug in another one. This might give you like parameter where you can like swap that out or something, and then another set of templates might run and give you the opportunity to do that.
So where do you build the charts? It's not in Argo. It's just VS Code, or is that somewhere else?
Yeah,
I've never seen it. I'm sorry.
Yeah, no, let me just show you. Charts are actually just in my, they're just in my repository. So,
Okay.
so these are the 3 ones. This app bundles these two into one. Okay, and then here I have a front end, and inside of here, so I was like, it's a templating engine. So I have the values for the template. These are just different values that get plugged in. So there's the image, the repository, right? And so if we just look at that specific one, the template is like a deployment YAML. This is going and finding those values, and it's injecting them into these templates. So for example, where it says container name and image, it's going to go grab that value that was in the values file.
So Helm charges YAML files.
Yeah.
Gotcha.
Pretty much. I mean, so there's also like, there's a repository for storing them, and
Understood.
yeah, there's a larger system around it too. So if like somebody develops a Helm chart for a very commonly used service like a caching service like Redis, and they have it designed so that it can be like not just a single server, but operate for like larger installations, they can share that. I mean, you can just share it through Git, but you can also like install it into your own repositories and stuff like that.
Thanks.
Yeah, one thing, the way that I learned it, when they started, no, it's fine. I'm Q1, I can go. I learned it was, imagine that Helm is more like Snap if you're in Ubuntu, or if you're in Mac, it's Brew. And then the charts is like the package repository where those snaps are, or where brew sh is, where you say install VS Code, brew install VS Code, and you just go to a GitHub repository, bring it down, do the compilation, all that. So Helm is doing something very similar to that, but instead of just crunching a bunch of YAML with some templating, like Josh was saying, you just put them together.
Cool.
And there's another tool, Customize, that does very similar, it's just in different.
Will you use your example here as a sort of showcase or
Yeah, I mean, it's just meant as like a starting point, basically. I mean, there's still probably lots of stuff that you would start having to strap onto this, but this gets you pretty much like most of the way there, at least with running a single Kubernetes cluster in a single environment. Like if you wanted to start doing like, you know, proper development, you're gonna need multiple environments, and you're gonna need to configure a lot more things. And answer a few more questions about maybe is Argo being shared across multiple clusters? Because yeah, it can do that. So there's certain things that maybe start to factor out depending on your environment.
Actually,
So why Argo versus other GitOps tools?
There's only 2 that I've been made aware of. I think the other one started to dip, I think, in popularity, or went bust even. I'm not sure. It's just the first one I chose. I don't know the answer.
I'm just curious.
Yeah, and I'm not like a fanboy.
No. The last environment that I worked in was a lot of Kubernetes. We were migrating off of Netflix's thing to Argo. So
Yeah, I think it's gotten the most traction. For my
Which
Well,
one?
it's commercial, Foundry,
Yeah.
Forfeit, or Armory, yeah.
Plus, this has a better icon.
Oh, Armory, yeah, I used to use
That's the
Armory
best
a
reason
lot.
right there.
We used to use Armory a lot, yeah. It's-
Yeah, so if we wanted to, we should go to github.com/jstop and
Yeah, you can run this.
Click on the-
There's a
the
couple
three.
requirements to get this running, and it's only against AWS, so you need an AWS account, you need to set up a few other things, and you can do it.
okay. What's the AWS dependency? Can I run it locally?
That was just the way I originally set it up, so a lot of the automation is leveraging packages that were meant for deploying against AWS. They're called and specifically using EKS, which is the Kubernetes package of AWS.
Okay.
You could swap that part out and then just use the Argo and charts and just mess with that too and run it against your own.
Cool.
But you have this.
To view the.
Yeah, go ahead.
Go.
To view the dependencies, wouldn't it be in the package JSON or in the view of like?
That is correct.
views?
So in this project, I have it split out so that the blueprint is where the actual like CDK application is. That's another AWS thing,
Okay.
which is being used to deploy all the infrastructure. And so in here, yeah, you can see all the packages are listed here. And yeah, exactly.
Right, okay.
Okay.
I have a question. Well, it's more like a comment, because I did check out your, I checked out your repo and I actually tested out.
I didn't see no star.
Huh?
I didn't see no star from you.
Oh, I did.
I didn't see nothing from you.
So the,
I wanna check that.
I will. There you go. So here's the thing. So can you kind of like explain some of the project that you brought up, because I think that's pretty
Yes.
interesting for them to know, because if they're gonna try, they might want to know exactly what they do. So because it's interesting, the project that you picked, I was interested. So.
Blueprint probably
Yeah.
is one that you're interested. Yeah, so this one's great. Yeah, I mean, I'm not a CDK developer. I was actually mostly a Terraform developer. So when I was tasked to do this, they said do it in AWS because that's what we were a consulting company that does AWS.
Mhm.
And they also said do it in CDK, and I was like, I don't know. Okay, we're gonna get started with CDK, but the first thing you do is you go and see everybody's built the wheel already.
Yeah.
You know, so I went and started searching. And this was the best one I came across, and it's I think it's like AWS kind of managed for deploying EKS clusters in AWS, and it comes with a whole lot of really cool built-in features for kind of setting up your cluster with a lot of the best practices without having to do a lot of work. So it has these things called add-ons, and these are a lot of the things that add to the cluster. So for example, yeah, Argo is one of the ones I used. There's I think a load balancer controller. So these packages, what they'll do is they might install even their own Helm chart or something into the cluster, and that'll set up some services, and it'll give the services maybe service accounts. So for like an AWS load balancer controller, that'll set up maybe a container inside of it that has the code to spin up a AWS load balancer, and then it'll join it with an IAM role, which is a security privilege that it'll connect to, and that gives the whole thing like the ability to set up its own load balancers to feed to your applications. So there's lots of stuff in here. It gives you a lot of resources around security, so you can set up like different teams with different levels of kind of access within your cluster. It's all AWS, so it's like you can just assign different roles and different users to have access and privilege to specific applications. So if you're running like various workloads and with various teams in a large organization, this helps you to get a security practice in place right from the start with varying access.
So when you say security, meaning no one can just enter this without having this, like without having the permission from this big setup, is that what you're saying?
Yeah, this will set up basically user permissions to the Kubernetes CLI. So if you have to, when you're setting up one of those applications, you're going to use the Kubernetes API to do a lot of those things. So this will kind of give you the foundation to set up like who can access maybe a specific namespace. So if you have one application and it's running under one namespace and one with another, you give one team an access to a role, and then it separates who can access what. Yeah. Good?
Okay.
All right.
Alright. Okay, so we closing talks. So one thing that I want to highlight about Josh, if I may, like I give him a hard time when we're working together because I put him stuff. But I want to say basically that he's a person that actually tries things. I like that about him. Like whatever it is, just try it, even if it's tough. So two things, actually three, before we go to eat cake. So one, please remember to sign up on the group, the Kubernetes of Florida, is that where you're gonna get all the notifications. We want to do this monthly, so we want to get back into the in-person meetings instead of just all being virtual. We want to bring more topics, so if you have any topics that you wanna kick over, please let us know. I'm gonna put you on the spot, Damian. I think we're gonna be doing something at the end of the month, right? On June, on Damian's meetup, and we're gonna join the meetup that day, so we do the same in one. Where we're gonna we're gonna call it more like a workshop, and what we're gonna try to do is go from 0 to 100 on Kubernetes. But the way that we're gonna do it is gonna be for like you know nothing about Kubernetes and you want to deploy applications, we're gonna go do that in that workshop. So I invite you to do that one. And the third one, I'm missing something, I'm pretty sure. Can you remind me? Sorry. Good.
Well, we are also trying to do the meetup in North Miami. We have a venue. So, if you know anyone who's in Miami and kind of hesitant to drive out here, just let that person know. We'll be doing one in North Miami.
There you go. Yeah, we're trying to do the tri-county thing, so we're gonna probably shift between the different counties so we can help as many people. That's pretty cool. And the third one that I forgot, yes. Definitely we want to build a community here. So please invite people, let them know. This is not just about Kubernetes. I know that we're talking about Kubernetes because it's the birthday, but we talk about a lot of cloud. So it's cloud native and Kubernetes. So everything that falls into that we want to talk. So like for example, AWS, Google Cloud, whatever you guys want. We didn't talk about bare metals, why not? So the idea is to basically bring that and make it accessible to everyone. And that's pretty much it. So let's go eat cake. This is open mic, so please any questions, anything that you want to talk.